Now, in this video, we will going to discuss about the simple stress and strain. What is stress? The force of resistance per unit area offered by a body against deformation is known as stress. The load is the external force which is acting on the body, and it is applied on the body while the stress is induced in the material of the body. When the external force is acting on the body while stress is induced in the material of the body. If this resistance offered by the member against a deformation and the applied force or load are equal, the resistance offered by the member against the deformation and the applied force or the load, if both are equal, then it will be in equilibrium condition. So that means when the external load is applied and also the resistance offered by the body, both the loads becomes equal. The resistance is offering, that is basically because due to the external load is applied on the body. In such condition, then the loaded member is in equilibrium. That is, in equilibrium condition, the resisting force will be equal to the applied force or load. So mathematically, how we can write? Mathematically, the stress can be written, which is sigma will be equal to the applied force divided by the cross-sectional area. So what is sigma? Applied force is nothing but P, and the cross-sectional area is nothing but A. So P divided by A, where sigma is nothing but the stress, P is nothing but applied force or the external force, and A is nothing but the cross-sectional area. So what are all the unit of stress? So the unit of stress is Newton per mm square. That is basically because it is the applied force is in Newton and the cross-sectional area is in mm square. If you are continuing it in Newton per mm square, or if you are trying to define, if you are trying to evaluate by using the meters, then it will be Newton per meter square. So we are going to have some conversion factors. 1 kilonewton is nothing but 10 to the power of 3 Newton. Similarly, 1 meganewton is nothing but 10 to the power of 6 Newton. 1 mega means 10 to the power of 6. 1 giganewton is nothing but 10 to the power of 9 newtons. Similarly, 1 Newton per meter square is nothing but 1 Pascal. So that will be 1 Pa. So 10 to the power of 6 Newton per meter square will going to be, what is 10 to the power of 6, which is nothing but mega. 1 meganewton per meter square. 1 Newton per meter square will be equal to 1 Pascal. So 10 to the power of 6 Newton per meter square is nothing but 1 MPa. So similarly, 10 to the power of 9 Newton per meter square is nothing but 1 giganewton per meter square, which is nothing but 1 GPa. In the stress in SI unit can be as Newton per meter square or Newton per mm square. Then 1 Newton per mm square is nothing but 10 to the power of 6 Newton per meter square, because 1 mm square can be converted into meter square by multiplying with 10 to the power of 3 the whole square. So that becomes 10 to the power of 6. Since it is at the denominator, when you take it to the numerator, it will go to become 10 to the power of 6. So 1 Newton per mm square is nothing but 1 MPa because of 10 to the power of 6 Newton per meter square. So 10 to the power of 6 is nothing but 1 mega Newton per meter square. 1 mega Newton per meter square is nothing but 1 MPa. If it is given in MPa, that means you can take the problem directly into Newton per mm square. See, basically these are the very essential conversion factors which are going to be helpful when you are trying to solve the problems. So it has to be bear it in mind. Similarly, 1 Newton per mm square, which becomes 1 meganewton per meter square or 1 MPa. And then comes with the strain. So what is the strain? The ratio of change in dimensions of the body or deformation to the original dimension of the body is known as strain. So change in dimension of a body or deformation, or change in dimension of body or the deformation to the original dimension of the body is known as the strain. Of course, strain is the dimensionless and it is denoted by epsilon. So mathematically, how we can write the strain will be equal to the ratio of change in dimension of the body or deformation divided by the original dimension of the body, which is delta L by R. So this will complete the stress and strain. And those who like this video, you please give us feedback and also please subscribe to my channel. Thank you.